Okay, yeah, overfilling and overgreasing are just as bad. When we overfill with oil, we create churning action. So as the bearing is rotating, it starts churning through the oil and it has more drag. So we have to put more power in to operate the system. But secondly, when we overfill with oil, also the oil level can start to leak out past the seals.
Ketemu lagi dengan saya. Maaf, Bapak-Bapak dan Ibu-Ibu, selamat siang. Ketemu lagi dengan saya, Chandra. Kali ini kita akan membahas tentang lubricant management, prevent failure through control lubrication task. Di sini saya akan ditemani dengan salah satu praktisi lubricant internasional yang berasal dari UK. Mungkin bapak-bapak dan ibu-ibu pernah juga ada yang ketemu karena beliau beberapa kali datang ke Indonesia untuk melakukan training di machine learning lubricant analysis saat itu. Nah, ini ini. Halo Martin.
Hi, good morning. Selamat datang.
Okay. Oh, good morning from your side. Yeah.
Yeah, good afternoon.
Here is already 2 p.m. right now.
2 p.m. Yeah.
Yes, yes. Okay. This is Martin, Managing Director of Q Engineering Ltd, and he already trained many lubricant analysis in worldwide, and he also manage lubricant management in every industry, since like oil and gas or power plant and others industry. Okay. Before I start, Martin, may I explain a little bit for to the participant of this webinar?
Yep,
okay.
Please go ahead.
Oke. Oke, Bapak-Bapak, sebelum kita mulai, mungkin saya ingin memberikan gambaran secara lebih jelas bahwa bahasan kita kali ini, prevent failure through control lubricant task, ini kita akan membahas banyak mengenai bagaimana sih sebenarnya mengelola lubrication agar bisa lebih optimal dan bisa mencegah failure terutama. Ya, seminggu yang lalu sebenarnya saya sempat memberikan polling di LinkedIn untuk kira-kira di tempat-tempat Bapak atau Ibu gitu ya di site, ada nggak yang pernah mengalami salah top up oli gitu, dan ya 40% dari responden bilang mereka pernah untuk melakukan top up oli. Padahal itu kan simple tetapi bisa menjadi kesalahan dan itu bisa menyebabkan failure di komponen-komponen di sana. Dan yang kita akan bahas mungkin mengenai detail bagaimana kegiatan maintenance itu yang kita bisa masuk di dalam aset manajemen. Jadi bagaimana kita melakukan managing managing untuk oil, memanage pemeliharaan dalam bentuk greasing maupun penggantian oil gitu ya. Dan kita juga akan membahas mengenai bagaimana PTM teknologi maupun condition management mendukung kegiatan-kegiatan itu sehingga bisa lebih optimal gitu ya, dalam bentuk data dari data-data misalkan ultrasound atau data-data dari proses greasing dan seterusnya. Dan tak lupa untuk memastikan bahwa memang ini di-manage dengan baik, kegiatan greasing dan seterusnya, kita akan selalu didasarkan pada reliability management. Sehingga point prevent failure through a control lubricant test ini, kalau kita lihat dari tiara landscape di expectation flow, kita akan membahas detail di performance dari kegiatan maintenance kita gitu ya. Kemudian yang didukung oleh teknologi PDM teknologi dan condition management yang didasarkan dari life cycle strategy. Sehingga kalau information flow-nya nanti yang akan mungkin kalau Bapak-Bapak ingin melihat detailnya, mungkin dari data-data yang di-manage di sebuah software, bagaimana itu data-data dari proses greasing, kemudian data-data dari teknologi-teknologi PDM bisa mendukung untuk kegiatan optimalisasi greasing tadi gitu ya di asset management. Oke, itu mungkin introduction dari saya. Selanjutnya saya serahkan ke Martin untuk menjelaskan bagaimana mencegah failure komponen melalui kontrol lubricant. Okay. Please Martin, you can start the presentation.
Okay, thank you and welcome to the presentation which was introduced by Chandra there about prevent failure through controlled lubrication tasks. And as you saw from the introduction video, we need to be able to have the knowledge to do the job right. And part of that, of course, would be training. But the other part of it is also providing the procedures and the steps so that we get consistent performance. And this is why, as an overview to this webinar, let's have a look at what we're going to talk about. Why the need for procedures, firstly, then look at how you go about creating the procedures, and then look at where all of this fits within the whole 55,000, and particularly where the new Icml 55 standard fits as a subset of ISO 55,000. So if we begin by looking at why the procedures, why do we need procedures in the jobs that we do? Well, research done by Drew Troyer, a good colleague of mine and good friend, he did a lot of research for an article on Reliable Plant Magazine, which looked at the issues with what goes wrong in the plant, why people perceive things go wrong. Part of it was procedural problems. So not having the correct detail in the procedure. The other part of it was also personnel and human error, not knowing what the next would be, not being properly qualified and properly trained. And there were other issues, of course, that pretty much came down to issues of training, design, management oversight, etc. All that was discussed in that introduction video. But the ones I want to focus on here are the issues relating to the procedural problem and the personnel issues, because clearly if we have properly documented procedures for our tasks, then we get consistency and there's no excuse for not knowing how to do the job right. And you may think that greasing a bearing or changing the oil is a simple task, but there are so many things that can go wrong, and people will attempt to do these tasks in different ways. So what we want to make sure is we're providing the detail through the procedure to ensure that problem doesn't happen. And of course, when we look at some of the typical human failures, you know, our problem is we employ people because they have a qualification. We employ a maintenance engineer because he has an engineering qualification. Maybe he has an engineering degree, and we expect that because they have that qualification, because they have that knowledge, that they also have the skill. Skill is not something that you get with a qualification. You get your qualification from university, from college, that qualification says you know the knowledge associated with the work. But what it doesn't do is it does not give you the skill to do the job. And the skill comes from learning from other people in the workplace. So hence you have your mentoring programs for your new employees, your older personnel, the people that have been employed for some time, will act as a coach or a mentor or a tutor to show people the actual skills they need for the specific task. And this is where the differentiation lies. We can have knowledge, but that means we don't have the skill. We have to acquire the skill by learning on the job. Now, this is why we want procedures, because procedures help to identify the skills we need. And they will then also ensure that the best practice method is being utilized rather than just any old method where people are taking shortcuts. So we need to address the issues of lack of knowledge, lack of awareness, lack of skills. We need to address that through the development of specific task procedures, and obviously, in addition, providing training on how to undertake those procedures. So not only do we need to write the procedures, we also need to make sure that people are familiar with undertaking the procedures. Because at the end of the day, our goal is to do the right work in the right way. Because often we're doing the wrong work in the wrong way. For example, we have a lot of planned maintenance activity, and we carry out the planned maintenance team without properly understanding why we have to do that. And that planned maintenance activity sometimes is not necessary, and sometimes it is necessary, but it's knowing the difference between the two. And this is where we need to have procedures to identify that, standard work plans and procedures that help to identify when the work is necessary, but then to make sure that the work that we're doing fits with the tolerance, the quantity, the quality, the materials and the tools, that we have the right tools to do the right job in the right way at the right time. So the actual purpose then of the procedures, I think, is fairly clear. And therefore, we need to look at how we can develop these procedures. And ISO 55000 is about having these procedures in place. The thing is, what we want to avoid is simply documenting what we already do. If you always do what you've always done, then you'll always get what you've always got. Now that sounds a little bit long-winded, but what we're saying is, if you don't change what you've always done, you won't find improvements. Improvements come through changing what you do. So what I'm trying to say here before we start on the development of procedures is that don't simply write down what you do. It's a good starting point, but if you want to bring improvements, you have to change what you do. And that means keeping in mind that as you develop your procedures, always be looking for a better way to do the task so that you can achieve the reliability gains, you can achieve the reliability improvements with your assets. So looking at the whole process of developing procedures, remember that consistency creates reliability. One of the things I see in a country like Japan, they have a very high track record of reliability. But what I have realized is that they have achieved that reliability through consistency. They will always follow a written task. They will always complete the process following the instruction. They don't attempt to take shortcuts. They don't attempt to rework it. They simply follow what's in the procedure. But that consistency brings reliability. Now, of course, in terms of procedures for maintenance, then we expect to find that we want these desired results by taking the technical standards and the process standards to create standard work. That's our desired result. That's the goal that we're trying to achieve. So the technical standards are detail standards, are manufacturing that stipulate dimensions, temperatures, ingredients. The process standards are the detailed work procedures, usually seen in the work procedure sheets and instruction booklets. So by combining that, we can then start to put the detail in place for our maintenance procedures. And the benefits then of procedures-based maintenance is that with these written and documented and controlled procedures, we end up with clear defined preferred practice. We have that consistency and continuity. We reinforce what we want as best practice. And it also helps through the process of creating this procedure, it also helps to define the training and certification requirements needed to undertake the task. Most importantly, of course, it enables improvements in safety, improvements in the environmental process, in environmental compliance, and of course that has a major impact for climate change. So clearly then there are a number of benefits that relate to having controlled and written documented procedures. Therefore, when we look at a typical procedure, for example, greasing an electric motor, a simple work instruction, we make the assumption that anybody can take a grease gun, walk up to the machine, attach the grease gun, and start pumping some greasing. But often we end up with guesswork because we don't tell the people what grease they should be using. We don't tell them what quantity of grease they should be using. So in a very clearly defined work instruction, in a very clearly defined lubrication procedure, we have a number of steps. Remove the dust caps from the grease fittings. Clean the grease fittings with a clean lint-free cloth. Inspect the grease fittings to make sure they're not damaged. If necessary, replace them. Then apply that many shots or that quantity. Now notice we don't just say shots, we say the actual quantity in grams or milliliters of the actual product to the drive end bearing, and the same again, but notice that it's a different quantity for the non-drive end, which often happens on electric motors, especially one like this with a belt drive. There will be a difference in the quantity of grease to be applied. Now, this is actually precision greasing taking place on an electric motor. We say apply the grease at a rate of around 3 seconds per stroke cycle. So as you pump the grease gun, take 3 seconds to feed the grease in. Don't pump it in too quickly, because what will happen is that creates pressure. That pressure could dislodge the shield on the bearing. It could cause the seal to get broached, and we could end up with grease on the windings. And if we find that there is back pressure as we're applying the grease, it could be that the feed tube is blocked with old hardened grease. So we're saying don't grease if there's too much back pressure, because too much back pressure means there's a problem. And if we try to overcome that back pressure by just generating more pressure, the grease gun is a powerful hydraulic tool that could then damage the electric motor if we were to persist in trying to clear that blockage. So consequently then, having these written work orders helps to identify the process. Now, obviously, for someone who goes out greasing on a routine basis, this will become second nature to them. This will become straightforward, something that they can remember without having to look at the detailed bullets. And all they're going to want to see when they get to the machine is a reminder of how much grease goes in at each point. But the point is that, or the focus that I'm wanting to give here is that with having this written procedure, if you get someone that is new to the job, they've actually got something that they can reference on how to do the job properly. And it's also something that the mentor or the coach can show the pupil how to do the job right. And we've got that consistency then. So these kind of lubrication procedures, we want to make sure that they're detailed, that they show the information at the beginning, they have embedded images that show exactly what's required, and they give details like the materials required from the maintenance planning point of view, that they show the preparation in terms of setup, so if we have to tape off the area for safety, and then give the execution steps, and then also provide a space for any observations. So maybe motor dirty, and we want to then put in a recommendation that the motor is cleaned because it's covered in dirt. That's preventing the heat dissipating from the motor, and that will in turn reduce the life of the motor. So there's lots of things we can be doing here. Let's take a look at the anatomy of a good procedure. That is, there will always be a unique identifier to identify what the task is for which asset, because we can have a greasing procedure generically, but we need that greasing procedure to also be specific to a particular asset in the plant. We also want to make sure that we've got the safety considerations. We want to make sure that we've got the materials prep list for doing the task. What do we need? Is it a can of oil? Which oil? What quantity of oil? And then we want the actual details specific to the procedure, along with any pictures or graphics that might be useful or helpful to the person doing the task, that will then identify where the various parts are on the machine. And an actual photograph of the machine makes a lot of sense. So clearly then, in terms of the procedure, as I say, we want each procedure to be linked to a particular asset. And that means we need to make sure we put the detail there. As we say, the devil is in the detail, or the best practice is in the detail. The wrong kind of procedure would be like this: check oil pressure, check temperature, grease the electric motor, tension the belt. But I have seen numerous work orders issued by the maintenance planner that look exactly like that. So for a typical conveyor, that work order I have seen a number of times, basically saying grease the electric motor, check the temperature, tension the belt, etc. Now, what we really want is to ensure that we give the details. So confirm that the oil pressure is between those 2 points. Be more specific about what you want in the inspection process. Be more specific about where that temperature should be at, and be very specific about what kind of grease, how many grams of grease, at which point drive end versus non-drive end. And then when it comes to tensioning the belt, make sure we're specific about the tension required in terms of the force and how to check that, what tool to use using a tension meter. Okay, so put the detail in the procedure, because it's the lack of definition in this kind of procedure that leads to the breakdown, because people will say, I didn't know. I did not know that the temperature should be below that point. I checked the temperature, but I didn't know that it should be that low or that high. I didn't know that the oil pressure should be at this point. We don't give people enough knowledge. Avoid the tribal knowledge. Avoid asking your colleagues, and what should the temperature be? Oh, I think it should be 80 degrees centigrade because my machine's, the alarm trips at 80 degrees centigrade, so yours will be the same. It's that kind of thing that causes incidents, that causes breakdowns. Okay, so in terms of developing and setting up with procedures, we have to start somewhere because it's a big program. There are lots of maintenance tasks that need to be documented. And even just for lubrication, in my experience, a typical plant could generate 2,000 lubrication tasks. And this is why the maintenance planner likes to combine these tasks into one work order so that they limit the amount of work order activity that's being created. And the problem then is that you get work orders that become multifunctional, that require a number of people or at least a number of skills to complete that work order. And at this point, it looks like a massive challenge, but actually we need to break it down into steps. So we need to set up a tool to create our procedures. And in its simplest form, it may just be creating an Excel spreadsheet and creating a Word document with a mail merge function and simply creating a template in Word to bring all the information from your Excel spreadsheet into your Word document. But once you've created the procedures, you've then got to manage the procedures. And that means making sure that the procedures get done on time, every time. And that means, of course, executing the procedures accordingly, which means then that we also have to make sure the procedures stay up to date, because what happens if we have a change of electric motor, our electric motor fails and we put another electric motor in place? Is it identical to the one that we've just taken out? If not, we need to update the procedure for that particular functional location for that piece of equipment. We need to then make sure that we are always maintaining our database of procedures and make sure that they're always up to date. So clearly then, the first steps really would be to perhaps audit your site and then look at the best practice implementation and design, and then educate, measure, etc. That would be the standard approach to achieving excellence in any category, whether it's lubrication or whether it's maintenance in general. But when it comes to the actual steps, we are going to actually have to follow some of these steps to create procedures. One of the things might be to consolidate the lubricants and then apply color coding. Then to survey the machinery to identify what procedures are required, and of course also any best practice upgrades that might be required. So do we need to put an oil analysis sampling on the machine? Do we need to move the grease nipples to a more secure, safe location away from the machine? Things like that. And then we can go about creating the procedures. Once we've created the procedures, we then need to make sure that these procedures become implemented and become part of the work order. So these procedures should be part of the work order and give the instruction on how to undertake that work order correctly. So the thing about doing an audit of your site is, of course, that an audit will identify how you perform. And in a lot of areas, what we find is that handling of lubricants and storage of lubricants are two key areas where most companies fall down. They do not score very well, particularly in the area of handling, of lack of staff awareness, lack of knowledge and skill, and lack of equipment to do the job right. So this audit process can help identify where you need to focus the effort. But inevitably, as I say, in my experience, it's always going to be one of the key steps to implementation will be creating procedures that allow for best practice. So in terms of consolidating lubricants, for those that have already done it, you could skip this step. But for those that might think we're using lots of different oils, we're using lots of different greases, why are we using so many different systems, so many different products? It could be because of complying with the OEM warranty, or because your purchasing department is buying the cheapest product at the time. But what we want to do is try to consolidate. So basically the first steps, and without going into too much detail, I want to focus more on the procedure development. Consolidating the lubricants is a useful step. And the reason why we want to undertake this is because ultimately we want to assign a generic code and a color code symbol for each lubricant we're using, because your procedure will refer back to the lubricant required. And so therefore, having this rationalized and having these color codes in place makes a lot of sense. So essentially what we're saying is start by creating an internal lubricant specification document like you see here. And also add in the supplier safety data sheet, particularly, as well as the product data sheet. But by having an internal document like this, this internal document becomes the reference. It becomes the guiding document for purchase. So with this document, you are saying to your lubricant supplier, you must supply me a lubricant that matches the performance and meets the physical specifications of my internal document. My internal document specifies the physical characteristics of the lubricant that I want, and it specifies the performance properties of the lubricant that I want. So now you are forcing your lubricant supplier to supply you the product that you need, rather than them selling you a product that they want you to have for a commercial reason rather than a technical reason. So basically, getting that color code is important, because what we need to do is make sure we refer to that color code in our procedures. So we may end up with a situation like this where we have a number of color codes all lined up on the document, and that becomes our reference for all of our lubricants. But we will then use these symbols individually throughout the procedures. So within the procedures, we will embed that into the procedure so that at a glance, we can see which lubricant we're going to be using within that procedure. Now, as I said, each piece of equipment needs to have a procedure. So the first step really is to map the plant. Now, most of you will be using an enterprise resource management system, whether it's SAP, whether it's Maximo, you've probably got a functional location structure in place for your plant. The trouble with that is that it goes down to machine level. It very seldom goes below machine level. But lubrication tasks are often done at a component level. So greasing an electric motor is not done at the motor, it's done on the bearings of the motor. And oil change isn't done on a gearbox, it's actually done within the sump of the gearbox. An inspection of the oil usually takes place within the tank on the turbine. So what we're trying to say is that we need to have the plant hierarchy, but we need to be able to go to a level lower than the actual machine. So we need to split the machine components up into the lubrication related components as part of the machine. So go below the level of the machine down to the lubrication component level. Now, once we've done that, we can then begin to identify the actual required procedure. So we identify the asset's lubrication needs by looking at what the component part is. Is it a sump? Is it a reservoir? Is it a tank? Because of course for that, we're going to have to work out where we have the volume, the location of any drains, and any other associated parts of that, that would be part of the procedure. Then for bearings, of course, any bearings that are greased, we want to make sure we know what those bearings are so we can calculate the required number of shots, because a lot of times greasing schedules are incorrect. So we have to take the bearing dimensions and calculate the correct quantity of grease required. Now, on automated greasing systems, we want to make sure we know the volume of grease required for the reservoir. And then we want to establish intervals for the activities and then create procedures for all of the above. So we must also remember that when we look at things like your tanks, your sumps, your reservoirs, there are some best practice upgrades that we can put on the machine to improve reliability. So for example, putting a quick connector on the fill and the drain port, that would allow us to attach a hose so that we can pump the oil into the machine through the quick connector with the hose securely attached to that quick connector. That way the hose won't come off, won't slip off the system, and the oil will stay inside the hose going into the machine, which will ensure that the hose will prevent contamination of the oil as it transfers into the machine. That is standard best practice upgrade in companies that we would consider to be world-class leaders in lubrication excellence. So it's things like that, fitting an improved breather. The existing breathers are frankly rubbish and a waste of time. The OEM puts them on because they're cheap, and the OEM is not that concerned about stopping the dirt because you'll have to buy spare parts. So we can improve the breathers. We can improve the situation with side classes. For example, we don't like using dipsticks. If we can avoid it, get rid of dipsticks, because it means lifting the dipstick out, wiping it with a cloth, introducing contamination. So sight gauges are a big improvement. And of course, as we said, if required, oil analysis sampling points should be considered as well. And it may be a case of upgrading existing filtration for the same reason as upgrading the breathers. And also grease points, as I mentioned, it may be a case of extending the grease point to a safe location. So we've seen instances where in order to grease the machines must be stopped because the safety guard has to be removed to get to the grease point. Well, it makes sense to just lift the grease point on an extension tube above the safety guard so that it can be accessed while the unit is running rather than having to stop the machine and interrupt production. Now, of course, with our procedures, we want to ensure that we are bringing in the 5 rights of lubrication. And the 5 rights of lubrication are the right lubricant at the right time, in the right quantity, at the right place, and above all, with the right attitude. So with the right lubricant, color coding and make sure that's going to be in the procedure. At the right time, so we want to make sure that things get done on time as per the schedule. And so our procedures will identify the intervals required, which will then be put into your work order planning system. In the right quantity should be detailed as part of the procedure. And at the right place, there should be a photograph highlighting where the right place is. And the right place should have its own little tag identifying the quantity and the type of lubricant. And of course, the procedure then helps to ensure that we are applying the right attitude to the process, that we are dealing with consistency to get that reliability. So in terms of the lubrication tasks and lubrication scheduling, some of those tasks are going to be planned and preventative work. And that's typically going to be general greasing of bearings, or it's going to be oil changes on small volume machinery. So those are the typical kind of planned lubrication tasks. We still want to have procedures for them, but that's the kind of task we might have to associate with that kind of machine. On the other hand, on the more critical machine, we may go for a condition-based lubrication approach whereby the tasks are done on condition. So based on oil analysis feedback, we might then have to consider changing the oil on a larger system like a hydraulic tank or a turbine. We might see evidence of wear debris that might suggest that there are problems within the machine that might need resolving. On the other hand, at a proactive level, of course, we can do maintenance of the oil using oil analysis feedback. We can determine when we might need to do some additional filtration on the tank or the reservoir. And of course, ultrasonic greasing or using ultrasonic feedback from a microphone can identify when greasing should take place. So basically, we want to make sure our procedures cover all of those aspects of how to do the job correctly so that we get consistency in the process. So when we've mapped out the plant and we've identified all the machines and we've then identified all the lubrication points on each machine, then of course we can start to put together our actual procedures. So we want to make sure that the procedure is identified, but along with an identification of what skill level or resource level is required. So for greasing, it may be a general lubrication technician. But on the other hand, for something a bit more complicated, we might assign it to maybe a mechanical technician or an electrical technician. Maybe the electrical technician is the one that will grease the electric motor. We want to then make sure we also enter a time to complete the task to assist the planner for the work order management. And then we should also make sure we put a priority on the task. Why a priority? Well, there will be times when there's a shortage of resource and a work planner needs to know whether the task can be pushed back. Now, unfortunately, lubrication is often pushed back. So when it comes to greasing, planners have a habit of skipping the greasing schedule because they don't see it as important or see it as a priority. So we want to make sure we have that priority attached to the procedure. So we can say that it can be pushed back by 1 week, it could be pushed back by 1 month, or it could be skipped altogether. Unlikely, but we need to give some sense of priority about the task. But also for the work order planning and for the efficient time utilization, we should also make sure that that task is part of a route. That route being a route that you follow through the plant to do the actual work, because we're going to group some of these tasks together. So for example, it would make sense to take all the greasing procedures using product X as a grease, and then ask the lube tech to then go and do that greasing with that grease gun, following a route through the plant that is most efficient for greasing all the units. Don't forget, of course, also scope or purpose for the procedure, materials list, tools list, but very importantly, any safety issues associated with doing the task that the person should be aware of when they start to undertake the task, a preparation checklist, and then, of course, the actual task description route. All of this is very important as part of the procedure. And we end up with something that might look like this, where we've got our actual lubricant symbol clearly highlighted at the top of the work order. We've also got an image embedded where we've got the annotated points showing exactly where the greasing takes place or where the oil top-up point is for the unit. So you can see how we can bring this together. Now, we've not sat down and individually typed out each of these documents. What we've essentially done is we've done a merge of information into a template, because to be honest, the actual specific steps are all fairly similar. So it's really just a case of bringing in specific detail to this template, such as the image, such as the information about the oil, such as the actual component name, the tag number, the quantity of lubricant, etc., etc. And once we've got all of that into our tool, into our software tool, we can then generate these procedures very, very quickly. And I've done this a number of times for clients using a tool that I have, Cubic, where it allows me to do things, not just to create these procedures, but to do other things like adding in tags for the machine. So now we've got a tag for the greasing of the air blower. So the air blower bearings, we've got this tag that we can generate and hang off the actual greasing point that gives the specific detail as, again, a reminder of what should be done, how much grease should be used, at what point, and the same again, tags for tanks, etc. So once we've got all this information into the database, we can generate the procedures literally in seconds using the template structure to bring in the specific detail. And then we can create things like tags to hang on the machine. We can create other forms of tags that we can put on the drums of oil in the oil stores, for example. But once we've got all of these lubrication procedures into the system, the planner can then begin to look at all of that information and make sure that those procedures are attached to specific work orders. And of course, we then have to make sure that all of this works, that the routes are sensible, that the amount of tasks generated for each route are sensible and meaningful, and that we are not trying to overwork anybody, that we're not trying to generate too much effort, that it is all manageable, okay? Now, once we've got all of that in the system, for reliability engineers, asset history is very important. Reliability engineers rely on the information that's been collected about the machine over the years. It helps them make judgments about which are the bad actors, which ones need the most attention. But we can also make sure that we capture information about our machines when we go out to do these work orders, when we go out to do these procedures. Now, a reporting system is very, very useful for that. It's also very useful for identifying what improvements need to be made. So if you've captured all of the information about the best practice up,
Martin, could you refresh your browser? Freezing, ya. Martin, could you refresh your browser, Vmix browser? Could you refresh your browser? Tulis aja di situ. Frozen. Internetnya dia. Oke. Hah? Aku masak atau gimana? Enggak juga, enggak ngerti. Oke.
okay. You can hear me okay again? Hopefully it's working now properly.
Yeah.
Yeah, excellent. Okay. Apologies for that. I'm not sure where the internet is obviously always a bit unpredictable. So my apologies from my side if it was my end. So anyway, we're not frozen now. We can clear that. So as I say, reports will be very useful to the work, to the planner, to the maintenance planner, because the report will identify what upgrades will be necessary, because some of the upgrades can be done perhaps while the machine is stationary, but some of the upgrades might be required when the machine is actually down for maintenance, such as doing an oil change or something like that. And some of the improvements might need to be implemented as part of machine rebuilds. But don't forget, of course, we must also make sure that when we specify new equipment, we also want to make sure that these fittings are featured as part of the new equipment specification. So in terms of the reports, they can also aid scheduling. They can identify when some tasks are not being completed, when they can identify what volumes of oil are in all the machines, what types of oil. So that can be run, and also even just checking stock levels if necessary. But the system that you're using should make sure that you can actually check up on these procedures. However, the daily routines and the planning, obviously that's the job of the maintenance planner. Your procedures should identify all of that information that's going to be required for the maintenance planner. So the area, which part of the route, what's the task priority, what's the skill level required, what is the actual task type, all of that should be available to the planner once you've created your procedures. Okay, now of course also, like I said, reliability engineers want as much information as possible. And so typically we want to make sure that when we are completing these procedures, we're gathering information. So like the example I gave earlier, I said motor dirty. Now, if that was reported numerous times, why is the motor getting dirty? What's the problem? Is there a way we can try and prevent that happening in the future? Or maybe motor running hot, because we can then start to collect the information, the feedback, because often when these procedures get completed, especially lubrication task procedures, they just get signed off as completed. They don't tend to gather information. But, you know, a lot of times your lube tech is actually at the machine doing these tasks and could be doing an asset inspection. And that asset inspection would then identify, any other problems that need to be reported that then can be acted upon. Okay, so essentially then, with the lubrication procedures, what we're saying is that we want to get the basics right. And the way to do that is to document what gets done. But the most important thing is make the easy thing to do the right thing to do. If you want to encourage people to take on a new way of doing a task, then you have to make it easier for them. You know, people are funny. We tend to do what we've always done because we feel comfortable with it. It's what we know. So in order to encourage people to do the right thing, make the task easier. So for example, if an operator is leaving a jug of oil by the pump for doing top-ups, then that's probably his easiest option. Let's make it even easier. Let's make sure we provide the operator with small sealed bottles of oil in a box that he can keep at his workstation. Then he can take one, fill up the bottle, and that's it, job done. We're not leaving an open jug of oil beside the machine. We are providing him with the sealed, pre-filled bottles of oil that are clean, that he can use, and he puts the empty bottle back in the box, and someone collects the box and refills the bottles. So make life as easy as possible for everyone, because that way everybody will always follow the procedure consistently. If we make it complex, people will always look for a shortcut. And when people start taking shortcuts, then your procedures, you may as well give up and go home, because nobody's going to follow your procedure if they're too complex. Encourage best practice by setting up purpose-built storage units in the areas for the lubricants, so that in terms of carrying out these lubrication procedures, make sure that they're easily achievable. make sure that it is possible to undertake these procedures. And then, of course, make sure people are trained on how to use the procedures, but also in the knowledge required to use those procedures. But remember as well that you won't make all of this happen on your own. Obviously, it's part of a team process. And there's a culture change required. So as you saw in the video at the beginning about ISO 55000, it is about a culture change. And so you need to make sure that you have a lubricant champion within the business, because that lubricants champion will try to drive that change forward. But also remember, like it said in the video, educate and lead by example. Make sure that everybody is doing the right thing and be seen to be doing the right thing. So the next step then, of course, is how lubrication fits within the context of ISO 55000 and the new Icml 55 standard. So consequently, when I look at ISO 55000, I tend to think of it as a bit like ISO 9000. So some of you are familiar with the quality standards, ISO 9000. Basically, ISO 9001 is a quality standard for manufacturing. And effectively, you are documenting how you're going to produce a product. So 9000 had benefits for the industry because it brought quality to production. We need something like that for maintenance. We need a standard that kind of brings that benefit to maintenance. And 55000 is an asset management standard. In fact, it started out as a publicly available standard 55, which of course has been superseded by ISO 55000. But 55000 was rushed through eventually by 2014 in terms of the disaster that BP had in the Gulf of Mexico. It was the result of that that drove the change, the cultural change to have ISO 55000. Now, at the moment, it's not a requirement. And just like 9000 was not a requirement to do business, but more and more customers kept saying, are you 9000 qualified? And I think what's going to happen is more and more people are going to be asking the same question going forward. Is your business 55000 qualified? And of course, that will then have an impact on things like your insurance. And so the cost of doing business will be cheaper as a result of 55000. But the biggest reason that business will become cheaper in terms of operation and business will become more profitable, that is because of the reliability benefits that 55000 brings. So as part of that process, of course, 55000 was about asset management. And if you took the word asset and replaced it with lubricant, we effectively have Icml 55. Now, many of you will be familiar with the International Council for Machinery Lubrication. Some of you may have undertaken the Icml examination process and become qualified or certified as an MLA1 or an MLA2 or an MLT1 or an even perhaps these days as an MLE. So we have machine lubricant analyst, we have machine lubricant technician, and we now have machine lubricant engineer. So the International Council for Machinery Lubrication has been providing certification standards since 1999. But during 2019, Icml 55 was put forward, and basically 55000 covers all assets. PAS 55, or publicly available standard 55, kind of covered for the physical assets. And then Icml 55 is basically for lubricated mechanical assets. And from that, it covers a number of industries, it covers a number of asset types, and it covers a number of activities. So let's take a look at what the actual standard is. So it'll be in 3 parts, and all of this is available on the Icml website. All of this detail is there, but 55.1 is actually available now, and it is, in fact, the requirements for the optimized lubrication of mechanical physical assets. 55 Part 2 and Part 3 are not yet available, but Part 2 is the guideline for the optimized lubrication of mechanical physical assets. So as opposed to the requirements, this is the guideline. And then the final Part 3 is the auditor's standard practice and policies manual. So to give you an example of where Part 3 would fit, if you remember when we were talking about the procedures development, one of the things I'd said was the need for auditing. And in fact, just to give you a brief look back at that, where we were talking about was this. So for example, in terms of the audit, how do you currently perform? Then 55 Part 3 will actually be about how to undertake those audits and how to benchmark and reference and measure. So it will be much more of a comparable standard. So whether I do the audit or whether one of my compatriots in the business does the audit from another company, it's a comparable measure, okay? And in fact, you as engineers would be able to undertake that audit yourself because you'd understand what those guidelines, what those benchmarks and references would be. Now, Icml 55 was co-authored by a team of 45 technical contributors. I was actually one of those contributors on the standard. And what it is it offers a detailed physical, practical consensus of lubrication management systems and processes applicable to the effective management of lubricated physical assets. So it takes a comprehensive look at 12 interrelated areas of what we would consider to be a sustainable, world-class lubrication program plan. And 55.1 is written as an enabling standard in support of physical asset management in accordance with ISO 55001. So you can purchase the Icml 55 standard from Icml or through Chandra. Give Chandra a shout there if you want to get hold of a copy of the standard. So the 12 interrelated areas of Icml 55 and why it brings a benefit, of course, skills, the machine, the lubricant, the lubrication, and this is where we've been talking procedures. So the actual tasks and making sure that all of those tasks are documented and written up as procedures. It also covers the tools required. It covers inspection processes. It covers lubricant analysis. It covers troubleshooting, and it covers waste management, also energy and energy conservation, reclaim or reconditioning of waste lubricants, and then, of course, the overall program management, and particularly reference to metrics as a means to monitor the actual performance and make adjustments, because it's all part of that continuous improvement cycle. Okay. Now, the benefit of Icml 55, if you're still not sure what the benefit would be, the adoption of 55.1 and as augmented by the guidelines given in 55.2, this will enable an organization to achieve its objectives of effectively and efficiently managing its physical lubrication and lubricant asset policies, strategies, and plans. It identifies and defines requirements for what should be done rather than explaining how to do it, therefore allowing customization of the actual process to suit an organization's needs. So whether you're in power generation or whether you're in oil and gas, or whether you're in general manufacturing, you can take these and adopt them to suit your industry. So whilst it's intended to align with 55001, 55.1 standard is entirely a work product and exclusive intellectual property of Icml, and is not explicitly or implicitly endorsed by the ISO standard or any other standards body. So it is something that the Icml have developed independently, and as it says, it's not endorsed by any other organization as such. But when you consider that you've got people like Jim Fitch from Noria and numerous others from the industry that are considered world-class leaders in the topic of best practices with lubrication, and dare I say it, even myself involved on the team, I think it's a fantastic standard to use as a benchmark going forward. And I think it'll become the de facto that dovetails in or fits in very nicely with the whole ISO 55000 ideology. So in terms of who benefits from 55, Icml 55, asset planners, asset practitioners, and asset-rich businesses, of course. So all of those are candidates for Icml 55. They will benefit from the Icml 55 standard. What assets are covered? Basically, reciprocating and rotating machinery, any asset that requires lubricants, any finished products such as chain ropes, chain greases, wire rope lubricants, things like that are all covered by the standard. And then, of course, the non-machinery support assets, the people, the personnel, the procedures, as we've been talking about, the written tasks, all of that is covered by Icml 55. So what fluids are not covered? Basically, anything that does not serve a lubricant function. So it doesn't cover for fuels, it doesn't cover for independent additives that are sold separate to lubricants, it doesn't cover for transformer oils, it doesn't cover for solid lubricants. So it is primarily focused on lubricating oils derived from either crude oil or are Group 4, Group 5 synthetic-based oils. Now, just to sum all of this up, for me, one of the biggest reasons for having written documentation is the safety benefit. And doing more proactive work with a properly trained workforce using written procedures means that we have less reactive work, and less reactive work means less injuries, less reported injuries. More proactive work means a safer working environment with fewer reported injuries. More reactive work means more reported injuries. So I will leave you with that thought and hand it over to questions. So thank you very much for your time and effort and listening.
Okay, thank you very much, Martin. There's some question for the participant. The first one is coming from Pak Deprian. He asking about how to start creating procedure for a big plan with a big maintenance team that they haven't has any procedure before. Maybe how many people can create, like how many people, or maybe you have an experience.
Yeah, if you were to bring in an independent contractor to physically do this job, then for the lubrication aspects in a big plant, we're talking maybe 3-4 weeks for an independent contractor to work through everything on the site and create the procedures for lubrication. That's probably the extreme limit. If you were to do it yourselves internally, in my experience, these projects very seldom succeed because people have day jobs. They have to do their day job, and they don't get time to work on these kinds of projects as much as they would like to, unfortunately. So it is probably best to bring someone in from outside who can then do all the necessary work. So, for example, right in front of me, in fact, on my shelf behind me, I have a tablet, but I'm holding up my Surface tablet here currently. If I have that in a rugged case, I can go on site and I can take photographs of the machines. I have, as I mentioned, my Cubic software, which Chandra was also familiar with. We would collect all the data into that directly. And once we've got all that set up, it's literally a month to say 2 months to do a large plant, to do all the lubrication tasks. Now, that would also cover for things like maybe even documenting, for example, fasteners, what to do with the fasteners, what tensions required, what torque settings required, so that all the actual fastening points have an assigned value for the type of bolt, whether it's mild steel, whether it's stainless steel. So there's lots of things you could start to contemplate in terms of procedures beyond lubrication, you know, whether it's tensioning checks on belts, whether it's your fasteners and whether they're torqued down securely, that kind of thing. So hopefully that would answer his question.
Yeah, I think so. So maybe Pak Devian can ask me or from Tiara team to start the creating procedure. Yeah. Okay. Another question from SKF Sweden company. His question is, what does the user do in preventive maintenance, in this case for lubrication? For example, in an AC motor equipment, there is no motor nameplate. How many percentage damage motor dominant if we forget to lubricate motor schedule compared to other like insulation problems, sub-alignment, or bearing problem?
In terms of electric motor failure, a lot of the bearing manufacturers have put out information relating to bearing failure, and the majority, in fact, all of them basically say the majority of the time, the cause of the bearing failure on the motor is usually lubricant related. Now, that is, of course, looking at the root cause of the bearing failure, because motors fail for other reasons, as you mentioned, insulation, windings, and such like. So from the point of view of the bearings failing, it's lubricant related, whether it's actually missing the schedule, whether it's over-greasing, that's a common one as well, whether it's contaminated grease, those kind of aspects. Then generally speaking, the situation with regard to the lubrication being a problem, it's not an immediate problem in my experience. You know, you can miss the schedule once, you can maybe miss the schedule twice, but once you've missed the schedule over a period of, say, 12 to 18 months, the grease begins to get dry, it begins to harden, and then, of course, you get problems where you get lumps of grease getting pushed into the bearing, and then the bearing fails. The other problem, of course, is over-greasing, where the temperature builds up. Over-greasing means that the temperature gets hot because of the increased drag, and that temperature does not come back down again quickly. If you've greased correctly, the temperature will go up and then come back down. If you've over-greased, the temperature will go up and it'll stay up. Now, obviously, the hotter the bearings running, the shorter the bearing life. So a lot of these things that are lubricant related won't destroy the motor immediately, but they do have a impact in the potential service life, and they can reduce the potential service life of your motors from 15, 20 years to as little as 3 to 5 years. So these issues are not obviously immediate, but they will have an impact. And it's like in the video on 55,000, we become very focused on being reactive right now because we don't have the time to look long term, or we've got people that aren't looking at the long term because they already have decided that they're not going to be part of the company future. And this is the problem. I think to answer the question, a lot of motor failures are bearing related, and a lot of those bearing related failures are lubricant related. The bearing failure there is a root cause of the bearing failure, and that is very often lubrication through ignorance.
Okay, I think that's answer all the question. Another question is related previous question about what happen if we offer filling of the grease, and then what is the consequence if we offer filling the lube oil and the pump bearing?
Okay, yeah, overfilling and overgreasing are just as bad. When we overfill with oil, we create churning action. So as the bearing is rotating, it starts churning through the oil, and it has more drag, so we have to put more power in to operate the system. But secondly, when we overfill with oil, also the oil level can start to leak out past the seals. And we also start creating aerated oil, and aerated oil becomes a problem as well. So with overfilling, there are problems when we overfill with oil. When we overfill with grease, we pack too much grease into the path of the bearing. So for example, here's a bearing element, and as that bearing is rotating and moving around the bearing race, it will push the thickener to the side, and the oil will then lubricate the bearing surface. But if we overpack the grease, then the bearing has to keep pushing the thickener out of the way, and that creates drag, and drag then becomes heat. And that's why when you overgrease the bearing, it overheats, and it will stay hot for a long period of time, which will then reduce the potential service life of the bearing.
Okay. Another question from Jericho Sihombing. Okay, there is a long. Hi Martin, I have a question. We found a problem before from gearbox cooling tower. Temperature high until 90 degrees Celsius, and before 70 and 80 degrees. Yeah. The engine have a project to revamping system and adjust the blade for the blade fan from 11 degree to 7 degree. Can you give some solving problem for this case?
Okay, that sounds to me more like what you've done is you've changed the blade fan angle from, say, 11 degrees to 6 to 9 degrees. So you've altered the angle slightly. So that seems to me like you've put less drag on the fan blade, and therefore the temperature of the gearbox has come down. And I'm not sure that it is anything to do with the actual oil in the gearbox itself.
Okay.
But why did it change in the first place? Well, that's a good question. Before, it was at 11 degrees and running 70 to 80 degrees. Then it went to 90 degrees, but then they solved the problem by changing the blade fan angle. It seems to me like there's some other problem in there that maybe should be looked at more closely, or look for a root cause, because changing the blade fan angle seems like a sticking plaster solution. Does that, am I right in thinking that?
Yeah.
Yeah.
Because Jericho cannot explain detail. It seems that the temperature down is not coming from the lubrication. It's just from the flow.
Yeah.
Of the cooling.
Yeah.
Okay. Another question from Yan Pranata. How about slow rolling equipment with oil bed lubrication? Is there any consideration to do this kind of tasks, such slow roll speed, oil temperature, LPC? The operation mode of this equipment need to be standby at certain speed to provide emergency backup to parallel equipment.
Okay, so you got slow rolling equipment with an oil bath, and it is back up to the main system. So it's always just turning over slowly, just so that it's ready to go. Is that what you're saying, him?
Yeah.
So in this kind of task, I mean, obviously you want to still check oil levels. You want to make sure that the oil gets changed on time. But obviously at these kind of speeds, the oil's not going to become, it's not going to need changing as frequently, perhaps, as if it was running at full speed conditions. It depends what is the percentage of standby. Is it 50-50 between standby and main system, or is it 70-30? Because that may influence the oil change intervals. If it's 50-50, I would have the oil change intervals for the same for both machines. But if it's, say, 70-30 in terms of the runtime for the backup, then maybe I might have a slightly longer oil drain interval for the backup system. But certainly inspections, check oil levels, check oil color, things like that. Look for any obvious signs of problems. So, I'm not sure if there's much else I can add there.
So for inspection, is still need for the slow rolling equipment?
Yeah, I think it's still important to go and inspect everything and just make sure it's all working, that the oil level is okay, etc., because, you know, it's important that,
But the replacement of the oil is still based on the running equipment, or like condition of equipment, or like viscosity, or maybe particle count or something.
Yeah, I think, as I say, it will depend largely on how often that equipment is running compared to just ticking over. If it's only ever rotating slowly, then it probably doesn't need the oil changing as frequently. But if it is running maybe slowly and then speeds up to full speed for, say, 50% of the time, then it's going to need the, you know, I'd have to look at the standby versus runtime to decide what the oil change interval should be.
Okay. There is another question from Sandy Hasnul. He has a planetary gearbox. How many times, how frequent he should do the oil analysis for planetary gearbox?
How critical is the gearbox to their operation? Because there are a number of factors that will impact what that oil analysis should be. Typically on a gearbox, we're looking at about 500 hours normally, but it could be 350 hours. Is it a critical gearbox?
I think it's critical gearbox.
Then I would say probably 350 hours runtime.
Okay, 300. Or we can put it online monitoring for like just viscosity or something like that. simple.
Yeah, that'd be a good idea. Yep, put some permanently mounted sensors for maybe viscosity, moisture. Is moisture an issue on the planetary gearbox?
I don't know. Oh, what do you think? What do you think, Martin? Is moisture also?
Certainly, online sensors make a lot of. They are very good at identifying when there are problems and when an oil analysis should be taken. So yes, you're right in that using an online sensor for viscosity would be a good idea.
Okay. Another question from Aditya Limiarto. How to know the quantity of regreasing of initial fill grease in pin bushing? Do you know pin bushing application?
Okay, usually in terms of the first fill for the bearing, it would be the same as the actual quantity of grease for re-greasing. We normally want to make sure that there is a reasonable quantity of grease on the bearing during assembly. But unfortunately, you've also got all the feed tubes, you've got the cavity spaces, and so you need to make sure that those are pre-filled as well. So that's something that I find is probably better if you work with the, let's say it's an electric motor, and with the electric motor, it's rebuilt by a contractor. Then you should have an agreement with the contractor that they would make sure that all the first fill is done, ready. On the other hand, in terms of how to know the first fill, well, it's difficult without measuring it or without looking in the workshop manual. The workshop manual should tell you what the first fill should be, because, you know, we've got to fill up the feed tube, we've got to fill up the cavity around the bearing. So this is why the first fill is a difficult one to interpret, because we don't know the actual volumes of grease there without looking in the OEM or the workshop manual.
Okay. Another question. There's a lot of questions here. From Bukayambon. He said that he used bearing without regreasing or without grease. There is no space to greasing.
Okay, so you're saying they're sealed for life bearings and they've never been greased. They can last for 3 to 4 years. They can last longer, in fact, depending on the actual application. It can also last even longer. You know, for example, small electric motors on domestic appliances can last many, many years. The actual quality of the grease used, yes, in terms of sealed bearings, they use a high quality grease. And in fact, there was research done in North America on sealed electric motors. And basically, in terms of the bearing speed number, then if you know what the bearing speed number is, it's the bearing mean diameter times the RPM. So if you were to take the bearing mean diameter, multiply it by the electric motor speed, which would be, say, 1500 RPM, then if the speed number was in excess of 128,000, then it was better to have a lubricated bearing. So from a cost perspective, it was better to have a lubricated bearing than to have a sealed bearing. When I say lubricated bearing, I mean one that can be lubricated rather than a sealed bearing. All bearings are lubricated, of course, but the sealed bearings make sense when the speed number is below 128,000 financially. Technically, it's possible to have a sealed for life bearing with a speed number much higher than 128,000, but the financial cutoff point or the financial optimized financial benefit gain, 128,000. So it's usually small electric motors, small frame numbers, anything below a frame number of like 150, for example, is typically a sealed for life bearing. Now, they can run for many, many years because they use a fairly good quality grease. And when we say good quality grease, we mean probably something like a non-metal soap like polyurea, or a synthetic oil base rather than a mineral oil base. So, you know, what you'll find, of course, is that, you know, sealed for life bearings are used in many, many applications. And in fact, you've mentioned automotive industry, the actual automotive industry, passenger cars, motorcycles, scooters, etc. all use sealed for life bearings these days rather than lubricated bearings, or ones that you have to physically lubricate.
Okay. Okay. So there's another question from Aditya Jainut. What about in general manufacturing, such as automotive, like a CNC, is linear gate failure in CNC mostly caused by lubrication?
Yeah, I mean, any type of machine system that is got to guide the actual machining parts. So any linear movement, we want that linear movement to be as smooth as possible. And in order to have that smooth movement, we need to make sure that the surface is properly lubricated. And so consequently, you know, lubrication of linear guides is actually very, very critical. We don't want too much drag. So we want the actual machining unit to be able to move as quickly as possible as required. We don't want any delays in that process, but also we don't want the actual guideway to become worn, because if the guideway becomes worn, we're not going to get the tolerance on the machining side of the process as well. So yeah, I mean, linear guides in manufacturing just as critical as any other lubricated component.
Okay. Okay, that's all. The question for today. Anything to be added before we close this webinar, Martin?
No, from my side, I'd just like to thank everybody for your attention, and thank you very much for participating. And thank you, of course, to Chandra and his team at Tiara for hosting this and setting this all up. Thank you, guys.
Okay, thank you, Martin, for all your knowledge today. Dan terima kasih Bapak-Bapak semua atas partisipasinya. Hari ini kita membicarakan tentang lubricants management. Jadi kalau Bapak-Bapak punya rencana untuk melakukan pembuatan prosedur mengenai lubrikan, bagaimana mengelola lubrikan dengan baik, bisa kontak teman-teman di Tiara atau saya sendiri kalau Bapak-Bapak punya kontak saya. Oke, terima kasih atas partisipasinya. Selamat sore dan assalamualaikum warahmatullahi wabarakatuh.